Thank you for having me here. First off, I'd like to thank all of you for being here, and thank you, UNAVCO, for giving me this opportunity to speak on what I've learned this semester, or summer, sorry. School's in my mind. So, for those of you that don't know me, I'm Giordan Thompson. I'm a mechanical engineering student. I have 2 minors, one being in computer science and one being in engineering management. I'm from the University of Colorado Boulder. I go to school there, and luckily I was able to be born and raised in Colorado and wake up to this beautiful state every day. And yeah, I know nothing but Colorado. So to start off, my first day meeting Jim, he gave me 3 initial tasks. One being CNC machining. He wanted me to become familiar with that, kind of get UNAVCO going with that CNC machine. And then he also wanted me to 3D print some caps for the campaign systems. And then I also did a lot of campaign system testing. I did that a lot with my mentor, Bob. I don't know if Bob is here. Oh, there's Bob. So yeah, Bob helped me out a lot, taught me a lot, testing these systems, getting them ready for researchers, making sure they're not faulty, and doing that quality control. So going on in the CNC process, I had to really figure out what CNC is. And so CNC stands for Computer Numerical Control. It's widely used in manufacturing, not much with mass production, but a lot with customization and prototyping. This machine takes a code called G code, which I'll explain a little bit later, and it basically becomes a very highly precise tool that can cut metals in ways that many machines can't. So going on with the CNC processing, I had to start off by creating, here, I have the part right here. So, here, I'll just hold it up. So this is a rim bender. It's a bike tool. I've personally never used it, but no, I've never used it, but it is a good tool to learn what the CNC machine can do. So what I had to do is I took calipers, tape measure, whatever I could get my hands on to measure this tool and get the right dimensions. And so I took the dimensions and I made a CAD drawing above the G code right there, which I'll explain a little bit later. But so yeah, I made this CAD drawing. It's not quite exact of what this tool is, but it's very close. It looks like the tool. It's almost got the same dimensions, but I wasn't able to get everything exact. But from there, I had to create a toolpath, and this required a lot of knowing what these toolpaths do and really figuring out what bit sizes work best for certain cuts and things like that. And then from there, I take this design and export it as a G code from that software. And this G code, which is right here, basically all the G code is XYZ coordinates. The CNC is basically a big XYZ table that operates just using coordinates. And so I take this G code and I run it through a machining software called Mach 3. And so Mach 3 allows it to interpret the G code and basically talk to the machine to make it precise. And so from there, I went ahead and I had my CAD drawing, and so then I put my toolpath to the test, and this is what I came up with. So my very first machining session was right here, the bottom cutout. The only thing wrong with this cutout is that the UNAVCO symbol is not centered in the tool. So I had to go back and reiterate my toolpath. And then my second go was the top one. And this second go was good. Each session took about 4 hours to do. So yeah, it is a process. So if you do mess up, maybe another day. But yeah, so I got done with that, and then so I went ahead and I asked Jim to order some aluminum. And unfortunately, I was unable to get this part going because it cut out on me at 3 o'clock yesterday. But this is what I came up with. It took me a very long time to get this. It doesn't look like much, but it is. I'll explain. So yeah, it cut out on me. I don't have a tool. But what this teaches me is that it basically teaches me the general function of a CNC machine, and realize it makes me think of what UNAVCO can do with this CNC machine. And so I came up with some ideas talking to Keith and whoever was around, Bob, what UNAVCO could use the CNC machine for. And so I noticed we do a lot with enclosures. And so these enclosures have a back panel that AC and DC circuits sit on in the back of the enclosure. So these back panels take many custom screw holes and things like that. So I figured you could probably just stack 5, 6, or how many back panels you want, and then customize your hole drillings for those back panels. And then also a mount. There's many mounts that we can make for our campaign systems, which it would be something similar to this, cutting out. So you'd have to get a little bit further to where I've gotten in the CNC machine. But it's absolutely doable. And, you know, the customization UNAVCO can do with this machine is crazy. Really, we can figure out new reiterations and things like that best match our systems. So also I came up with, we don't do much with PCB circuit boards, but we do have the ability to draw electrical paths and drill holes for whatever you want to solder to that circuit board. So moving forward, oh, sorry, it went up. So moving forward is that my next task was to 3D print caps. I know, I'll get into it. It's great. So 3D printing, the 3D printing team, Jody and Dylan, helped me out a lot on this. But so basically what this is taking an STL file, something like my CAD drawing, and making it a tangible object. This also uses G-code like the CNC machine. You probably could make the CNC machine into a 3D printer. I just don't even know where to start with that. But the way it makes these objects is through an additive process. Basically meaning it builds things layer by layer. So it slices objects into a I'll explain later. But it's an additive process, and it builds these objects using layers. So this was our original cap that goes to the campaign systems. We're no longer able to use these caps anymore because our manufacturer no longer sells them to us. So I was told to make these caps by myself using the 3D printer. And so I got this file from Keith, and it was this exact cap. And so I went ahead and I printed the cap. And the only problem with this cap is it has these little notches on it. So when it's sitting on the printer like this, it has to use a lot of support material. So that takes a lot more time. So I went ahead and I got rid of those notches, and I made a division symbol, basically. This division symbol, you can use pliers, anything flat, for instance, like a flathead screwdriver, a quarter. But I'm not too worried about field engineers trying to figure out how to open this. Yeah, if that's a problem, then maybe we should figure out what we should do with those engineers. So, but maybe they shouldn't be out in the field. No, it's a joke. It's a joke. Sorry. All right. If you can't open the cap, okay. But okay, so to the left is a pass-through. Bob and I made 5 Polar RX-5 campaign systems that had to be shipped out for this this solar eclipse that's coming up, and so we didn't have them, so we had to make those Bob gave me that great idea. So it took me about 10 minutes to design that, and then to print that out took a little bit longer. But moving forward with that, this right here is a program called Slicer. Basically what Slicer does is it slices the object to make that additive process to make that additive process. So each cap takes about 36 minutes to print. And like I said, you export as G-code, you save the file to the SD card, and the printer prints from that SD card. So each cap takes 36 minutes. To get 4 to print, it's easy as a simple copy and paste, but that will take longer than 36 minutes to print. For instance, it'll take around 2.5 hours. So here's my finishing result. This is what the print looks like when it's done right off the printer. And this is the completed pass-through and the completed cap. And I also wanted to show you guys the 5 campaign systems. These are the parts being applied. Basically, we have the pass-through connected to the solar panel, and then we have the 2 caps, just a zoomed-in picture of that, those being applied. And then the 5 campaign systems getting ready to be shipped out. And that was them right next to the loading dock and ready to go. So why is this important to UNAVCO? 3D printing can benefit UNAVCO through prototype production. It's very good for prototyping. If you really wanted to, you could take your prototype and send it to China and get molded and manufactured and blah, blah, blah. But since manufacturing is not really needed for UNAVCO, because we don't really, sorry, I just have one more slide. All right, so yeah, waste prevention. No need for manufacturing because we don't need a wide range of these caps. And the world is ours for these campaign system customizations. If a field engineer has something to say about my division symbol or whatever, we can always re-replicate to their needs. And then my overall experience, I'm going to take my time on this slide because I'd like to thank you guys. This is actually a very, very good professional learning opportunity. I learned more here than I could have ever learned in the classroom. The technical skills I learned, I can't wait to bring them back to my TA position that I have in the fall. And I would like to thank you guys for making this such a welcoming environment. I've never felt not at home here. You guys are very warming. And also, I've developed many lasting relationships. So I'm going to be going around collecting business cards and exchanging with you guys just to make sure these relationships still go on. So yeah, thank you guys for this opportunity. And yeah, thank you, UNAVCO.